Let's address graphing sine and cosine functions. You're not going to have to graph a tangent function for target 8b. It's just graph cosine and sine functions. Now, if you practiced the asynchronous lesson and used the link I shared in Desmos and played around with the cosine and sine functions, it should be obvious, since they're both periodic functions, you notice that the sine of x is really the cosine of x that's been shifted, and vice versa. You can translate a cosine function horizontally and map it onto the equation or function in terms of sine. So I want to refer you to pages 9 and 10 of the lesson slides. This is page 9. The next one is page 10. The first one addresses the shape of a sine function. The parent function, if these values are 1 and 0, you get y equals sine of x. So I mentioned this in the earlier lesson. You can multiply both sides by b, add k to both sides, and you get y equals k plus b, the amplitude, times the sine of x, subtract h all over a. If your period is, the period of the function is 2 pi, then a is just basically 1. So the period of the function basically is the time, the horizontal distance of making one full circuit. This is equivalent to making one full circuit around the circle. From 0, let's start here, from 0 to 90 degrees, 180, 270, and back to 360, which is the same as 0. It just repeats. When you're writing an equation for a sine or cosine function, there are some steps that are going to be recommended. And I'll show you those. I'll show those to you right after I show you the cosine function. So where a sine function, if you imagine this is the y-axis. A sine function typically, well, it will start at 0, 0 and head up to 1, drop back down to 0, drop to -1, and then back to 0. The cosine function starts at 1 and then drops to 0, to -1, and back to 0. Why is this the case? Well, it's because there's that relationship between sine and cosine. If you are on the unit circle and you are looking from the perspective of an angle that is 30 degrees, from 30 degrees, that reference angle, opposite side is the side that is adjacent if you're looking from the perspective of the 60-degree angle. Okay, so that is why the equivalence of starting at 0 for sine, the opposite angles, or the other angle in this case, and they're not really angles because 0 and 90 are not angles of a triangle, but the reference points, so they're basically, let's say, opposite, but they're related. So if I want to turn this cosine function into a sine function, notice that sine function would go up here first. I would just shift it this distance. And if you have the x-axis labeled in terms of pi, then you will see that this point here would be pi over 2. If this is 0, this would be pi, 3 pi over 2. It's very easy to see. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4, so on. Okay. Now, writing an equation for these. Again, I've translated this equation into this form. And then if a is 1, it's written like this. you should already know the parts. K is the midline. K represents the vertical shift. The midline is the first thing you should look for. The midline is the halfway distance between the maximum and the minimum. Halfway between these 2 points is a midline defined as y equals some constant. Now in a parent function, that's going to be the x-axis or 0. So step 1, when writing an equation, look for the midline, which is k. Step 2, look at the distance between the midline and the minimum and maximums. So the distance between the maximum and minimum and the midline, so minimum to midline, maximum to midline, this will typically, well, it will be 1 for a parent function. If it's anything other than 1, then you have a b value, which is called your amplitude. If these maximum and minimums compared to the parent function are moved toward the midline, then the b value is going to be between 0 and 1. You can look at it as a compression. If they move away from the midline, the maximum minimum move away from the midline, it won't do anything at this point. These points stay at the midline unless that's translated left to right. But that would be a b value that's greater than 1. This is related to the the vertical stretch. This is related to the vertical stretch. Step 3, choose whether or not you want to use sine or cosine as the function. One will be easier than the other, and it will have to do with where you start. If this is the this is the y-axis, and I notice my graph starts somewhere above 0 and it drops, then I'm probably going to go straight to cosine function. If I notice that my graph passes through the origin, or I can shift it down or up to pass through the origin, and it goes up to some maximum, back down to 0 and down to minimum, then I'm probably going to use sine as my function. Once you've chosen cosine or sine to use as your function, then look to see which horizontal or phase shift you need to employ to get the equation you want for the graph. And then finally, the a value is the period divided by 2 pi. So the period is 2 pi times a. You find what the period is. The period is the amount of time, basically, or distance horizontally, where the graph completes a full cycle. That 2 pi divided by 2 pi gives you a. If the period is 2 pi, then a is 1. If I can get a full cycle in less than 2 pi, then that means my a value is going to be less than 1. If instead I notice it's taking longer than 2 pi to get to a full cycle, then it's stretched horizontally and I have an a value that is larger than 1. So let's put these steps, if you could record these, please pause the video, record these steps in your notes, and we'll try some problems together. So these are some practice problems I want you to try, and the entire list of them that you should be practicing on your own are on pages 19 and 27 of the slides in lesson 4, which is for Friday's synchronous and Friday's asynchronous lessons. And the answers for these are on pages 28 through 37 of the same deck, slide deck. All right, so let's use these steps. Look for a midline, look at the distance between the midline and the minimum and maximum, choose whether or not to use sine and cosine or cosine, look for a horizontal phase shift, and then finally, what is the period? For 1e, midline. My midline is the x-axis, so I do not have any vertical shift. Okay? Next, I'm looking for the distance between this midline and the maximum and minimum. It looks like the distance is 2, therefore my amplitude is 2. Now, if I shrink these back down to 1, I would get this graph. How do I turn this now in this graph here into a sine or cosine function? Well, it's dropping. So from here it drops. And if I look left and right, I could move this point there, and I could get the cosine function. To get a sine function, I could move this point here back to that origin. And so I've got two choices. I can either sine function that's been shifted from here to there, or a cosine function that started here has been shifted the negative direction. So I'll give you two choices here. Let's start with sine. So this is 2 times sine of x, and it's been shifted to here. From here, this distance is pi. It's shifted in the positive direction. Is there any, what's the period? The period goes from 0 up and back down to 2 pi. Period is 2 pi, so my a value is 1. Equivalently, this is 2 times the cosine of x, and then shift from here where cosine would start back to here. This is negative pi. This must be negative pi over 2, so I'm making that negative pi over 2. X subtract negative pi over 2 is x plus pi over 2. Either of those equations work for this graph that is in gray. Problem F. Midline first. Midline is at 1. I have a vertical shift of 1. Amplitude. Amplitude again is 2. 1 plus 2. Now, sine or cosine? Well, it depends. Let's see. Again, the shift, if it were going up, that would look like it would be doing here. So it could be sine function shifted from here, where it would go up and then down, back to here. That distance here is pi over 2. X, subtract the negative, pi over 2. Look for the solutions on pages 28 through 37 for the solution for the equation in terms of cosine. All right, moving on. Midline, 0. Amplitude, 1. Sine or cosine? Well, I want to go up, or I want it to come down from 1. It's coming down from 1. So from here down from 1, I'm going to use cosine. Now my period, where do I find one complete cycle or circuit, whatever you want to call it? There's 1, there's 2. Well, I get 1 in pi. I should get 1 in 2 pi. It's being compressed horizontally, and again, I mentioned that this will indicate that your a value is less than 1. So we have x divided by a half, basically. Let's use a decimal. B, midline. Midline is at -1, so y equals -1. Now I'm looking for my B value, my amplitude, the distance between the midline, the maximum and minimums. Maximum minimums are only 1 away from the midline, so there is no B value other than 1. So I need to then choose sine or cosine. Notice that if we shift this up, then it's going to start here, and it's going to look like this graph. So this looks like the sine function. It starts off at 0, 0, and we'll start there. I'm gonna, obviously this looks like it's been stretched. I'm gonna have a change in the period. So in a full cycle, from 0 to pi to 2 pi, that's only going up, it's not going down. But I see it's going down over here. So I'm going to look at the distance between -2 pi and 2 pi. That distance is 4 pi. So 4 pi divided by 2 pi gives me 2. My A value is 2. Sine of 1/2 x, or x divided by 2. All right, so I'm going to encourage you to do the others on your own. You can Canvas message me for support over the weekend. Message me and we can arrange a time to meet to go over these problems. 10 or 15 minutes will save you a lot of frustration. So check in, please.